Welcome back to our geometry series. Today we're up to section 6.1 where we will be looking at circles and spheres, but mostly circles. Here we have point O. Next we're going to put point A a length of r away from it. So we have segment OA with a length of r. A circle is a set of all points in a plane that are a given distance from a given point called the center. The given distance r is the length of any radius of the circle. So here we've drawn the circle. That given distance is r. And here OA is a radius. We can write circle O, or we can use this little symbol. It's a circle with a dot in it, followed by the name of the circle. Circles are named by their centers. So here, because the center of the circle is O, we call it circle O. And again, segment OA is one of many radii with length r. Let's draw another point, point B. B is still on the circle, and is still the same distance from O. So we have yet another radius here. So here's point I inside the circle. The length of OI is less than the length of the radius. The interior of circle O is a set of all points I in the plane of the circle such that OI, being the length of that segment, is less than r. So this green area here would be the interior of circle O. Here we've placed a point outside of the circle, E. So we've created a new segment, OE, which is greater than the length of the radius. The exterior of circle O is a set of all points E in the plane of the circle such that OE is greater than r. So it would be every single point outside of the circle. Here we've connected 2 points on the circle, A and B. We've created a chord. A chord is a segment that joins 2 points on a circle. Now let's move up point B. A diameter, usually d, is a chord that contains the center. It's the largest chord you can draw in a circle. So if we look at the segment lengths of OB and OA, this would be 2 times the radius, or the length of the diameter. Here we've drawn 2 points, A and B, on the exterior of the circle, but the line crosses through the circle. This is what we called a secant. A secant is any line, segment, or ray that contains a chord. So if we add points X and Y, where the line segment intersects the circle, we can see that AB is the secant containing the chord XY. So here we have circle F with radius FB with a length of 7. And circle A with a radius AJ also with a length of 7. 2 or more circles having congruent radii are congruent circles. This is the definition of a congruent circle. So, circle F is congruent to circle A because their radii are congruent. Let's draw another circle. Circle A with radius AG equal to 9. 2 or more circles having the same center are called concentric circles. So here we have circle F with 3 points, A, B, and C. We've created a polygon, in this case a triangle. If every vertex of a polygon is a point on the circle, like we have here, the polygon is inscribed in the circle. Likewise, the circle is circumscribed about the polygon. Next, let's look at a sphere. A sphere is a set of all points in space, so 3 dimensions, that are a given distance from a given point. Every sphere has a center, interior and exterior points, radii, diameters, chords, secants, etc. Just like a circle. If a plane intersects a sphere at more than one point, like it does in the picture here, the intersection is a circle. If the plane intersects the center of the sphere, then the created circle is a great circle, which would also be the circumference of the sphere. Let's jump to the whiteboard and do some examples. Okay, we're going to test my ability to draw circles here. So I'm going to draw a circle as best as I can right here. That's clearly not a circle. And I'm going to draw another one out here. And another one out here. Wow, these are not perfect circles, but you get the idea. We're going to put some points on here. This is going to be O, the center. And then I'm going to draw a line from O all the way out to this circle here. And we're going to start naming some points. This is going to be A, where this line intersects a circle. This is B, and this is C. So these little spots here where we have intersections. Next, I'm going to draw another circle with a center right here. And the center, well, let's draw the circle first as best as I can. Pretend that this is a circle that just fits in here. And we're going to draw the center, and this is going to be Q. And then I'm going to draw a line like this, and this point is going to be S, and we'll go straight down. This will be R. So let's ask some questions about this figure. How many concentric circles do we have here? Looking at O, it's the center of this circle with radius OA, but it's also the center of this circle, has radius OB, and then it's also the center of this big circle, OC. So we have 3 concentric circles here. Next, how many radii do we have? Now, radii being the plural of radius. So we have OA. Let's just write them all down. Radii, question mark. So OA, that's a radius here. OB is a radius. OC is a radius. QS, that's a radius of the smaller circle, and QR. So we have 5 radii drawn. Now we could take this point S and connect it to O and have a 6th radius if we wanted to. So right now we have OS as a newly drawn radius between O and S. So of these 6 radii we've drawn, which are congruent to each other? So let's start with a smaller circle here. We've got radius OA. OA. Is this congruent to any other radius in this figure? Well, this circle here has 2 radii, and the radius of any circle is going to be congruent to the radius of that same circle. So OA is congruent to OS. Likewise, down here, QS, this radius will be equal to QR, or congruent to QR. They're of the same circle, Q, so any radius is going to be congruent to any other radius of that circle. Alright, let's clean this off and do some more examples. Alright, I'm going to try to draw circles again. You know how well that goes. Here's a circle. I'm going to draw another circle here. Slightly bigger. And let's put some centers in. Like O for center here. And we're going to put Q for a center here. And what I'm going to do is try to draw a diameter right through here. So we have a diameter of O. And then the diameter of Q is from here to here. So let's add some more points. I'm going to call this point here, where these intersect, this is S. This is going to be R. We'll have U over here and T over here. Next, I'm going to label this point up here Y, and this point down here X. And what I'm going to do is draw a line through X and Y, like this. Well, that is not a straight line, but it's a line. I've got arrows on it. That makes it a line. And we're going to add a point up here, A, and a point way down here, B. So there's a lot going on here. So first, I want to look at circle O over here. And we want to name a point that is on the interior of O. Actually, there are 2 points that are on the interior of O. Can you find them? So it has to be somewhere inside the circle. So like Y is on the circle, R is on the circle, X is on the circle. But this point S is on the interior of O. And point O is also on the interior. So O and S are the interior points. So looking at O again, what are all the exterior points relative to this circle? So R is on the circle, Y is on the circle. A is an exterior point. It's outside of O. B is exterior. And so is Q and U. Now these points are, related to this circle. But if we're looking at just O, Q and U are exterior points. So let's do the same thing with circle Q here. What are all the exterior points of circle Q? Well, A and B are outside the circle. S is on the circle, so that's not exterior. But O and T are exterior. So we have 4 exterior points for Q. A, B, O, and T. Boat. Next, we want to list all of the diameters that we see here. So looking at this circle, what is a diameter of circle O? Well, the diameter is a line that connects 2 points, right? It's a chord, but passes through the center. So we have just that one line, TR. TR is the diameter of O. What about Q? Again, a line, a chord connecting 2 points that passes through the center is US, or SU, depending how you look at it. That is a diameter of Q. How many chords do we have? Remember, a chord is a segment that joins any 2 points on a circle. So we could look at this XY, right? It's a chord of this circle, but it is also a chord of this circle. So XY is a chord. But remember, TR, we call it the diameter, but it is still a chord. It just happens to be a very specific kind of chord that goes to the center. So TR is a chord, XY is a chord, and over here, SU would be the chord on this circle. And lastly, we need to find a secant. Remember, a secant is any line, ray, or segment that contains a chord. So in this case, we only have one secant. It's this line. AB is the only secant in this diagram. Okay, let's clear this off and do a bonus problem. Okay, I'm going to try to draw a circle here. Well, that's already not off to a good start. Okay, that's the circle. With center, O, we like O. And I'm going to draw a radius over here to point B. And we're going to say that that is a length of 10. And then we're going to draw another one over here to point A, which of course would also be 10 because, both radii, they have to be the same length. And then we're going to draw chord A, B, like this. And the last piece of information, and this is a letter O, not a 0, but it's the center, is this angle measurement right here. This is 120 degrees. So the measurement of angle AOB is equal to 120 degrees. So the question is, what is the length of segment AB, or what's the measurement? We could call it X or whatever, this is equal to X. That's what we're trying to figure out. Well, the sneaky part here is we need to take this angle of 120 and kind of cut it in half, right? And we end up with, 60 and 60 like this. Let's just rewrite that. I'm going to draw a solid line from O to X and call this 60 and 60. What I've done here is I've purposely drawn a right angle. So this is going from O to X. This is an interior point X. I've taken this 120 and cut it in half and bisected AB and created a right angle. So if this is 60 and this is 90, well, we're back to our 30, 60, 90 triangle again. So again, going back to our 30, 60, 90 theorem, we know that the hypotenuse is twice the length of the shorter leg. So if the hypotenuse is 10, this short leg here, okay, this is 5. That's easy enough, but we don't want 5. We're trying to find this whole length here. So we need to find the length of the longer leg and actually double it to get from A to B. We know that the length of the longer leg is root 3 times the length of the shorter leg. So the length of this leg is 5 root 3. That's from x to b. And the length from a to x is also 5 root 3. So AB is going to equal 5 root 3 plus another one of those, if I can squeeze it on here, 5 root 3. And we've already had some nice like terms here, so that just ends up being 10 root 3. And if we bust out Mr. Calculator, this ends up being roughly 17.32. So AB equals 17.32. And there we go. And that's it for today. We'll see you next time.